Hi, welcome back to Sakala Vidya Educational Channel. Today we are going to discuss Lagrange's mean value theorem. So now Engineering Mathematics 1. So today statement as well as the problems we shall discuss in this session. So Lagrange's mean value theorem. So what is the statement? Let f of x be a function such that first condition f is continuous in closed a comma b and f is differentiable in open a comma b, then there exists at least one value c belongs to a comma b such that f dash c is equal to f of b minus f of a by b minus a. So that means actually here f dash c is equal to f of b minus f of a divided by b minus a. So this is the Lagrange's mean value theorem statement. Simply we can say that LMVT. So actually in the previous session we left some problems on Rolle's theorem. So first let us complete the leftover problems and we shall switch over to the problems on Lagrange's mean value theorem. Okay. Let us move to next problems now. So that is problem number, okay, 1, write down, no problem. Verify whether Rolle's theorem or Rolle's theorem can be applied to the following functions in the intervals cited. So first question, f of x equals to tan x in 0 comma pi. So verify whether Rolle's theorem can be applied to the following functions in the interval cited, that we need to check. So now what shall we do now here? First of all, the given function is tan x. So let us check any one of the value in between 0 to pi, substitute that value. If that value gives us not defined at that time, then we say that f of x is discontinuous in that interval, then Rolle's theorem is not applicable. That only simple 3 statements we need to write, that's all. Solution, here given f of x is equal to tan x. See, in between 0 to pi, this is interval, for example, say this is 0, this is pi. So we have pi by 2. So let us check at pi by 2 the tan x is defined or not. We need to check. So that means now find f of pi by 2. F of pi by 2 is equal to tan pi by 2. Tan pi by 2 is not defined. Generally, mathematically we can write infinity. So that means the pi by 2 lies in between closed 0 comma pi, and also at pi by 2 the function is not defined. Since the function is not defined, it is a discontinuous function. But according to the Rolle's theorem should satisfy that f of x is continuous in the closed interval. So therefore what do we write now here? So f of x is discontinuous in closed 0 comma pi interval. So it does not satisfy this condition. That's why Rolle's theorem is not applicable. Hence Rolle's theorem is not applicable. That's all. Problem has been completed. Simple. So first, given f of x is equal to tan x radom. So in 0 to pi, the pi by 2 is there. So let us try to find out the value of tan x when x is equal to pi by 2. F of pi by 2 is equal to tan pi by 2, that is infinity. So that's why at pi by 2 the function is not defined. So f of x is discontinuous in 0 comma pi. So hence Rolle's theorem is not applicable or cannot be applied. Rolle's theorem cannot be applied. Second question. F of x equals to 1 upon x in closed interval minus 1 comma 1. So let us try to figure it out, this question now. Solution: given f of x is equal to 1 by x. So now this minus 1 comma 1, for example say this is minus 1, this is 1. So between minus 1 comma 1, 0 may be there. Yes, 0, right? So now find f of 0. F of 0 is equal to 1 upon 0. When x is equal to 0, the 1 by x is not defined, the function is not defined. So this is infinity. Here where 0 belongs to closed minus 1 comma 1 interval only. So f of x is not continuous in closed minus 1 comma 1. Hence Rolle's theorem is not applicable. Clear? Right. So let us try to solve one more problem. After that we shall switch over to the Lagrange mean value theorem. That is very, very important. So f of x equals to x square in 1 comma 3. Right. So now according to this problem, now here see, first given f of x equals to x square, the first point, f of x is equal to x square is a polynomial function. So f of x is continuous. F of x is continuous in closed 1 comma 3. It is also derivable. Second condition. f of x is derivable in open 1 comma 3, but among 3 conditions, 2 conditions have been satisfied by the function f of x. So that means third condition. What is the third condition? Now for example, this is a, this is b, f of a, f of b, we need to check f of a means 1, f of 1 equals to 1 square, so you have 1. So let us find out f of b means f of 3, that is substitute 3 in f of x is equal to x square, you get 3 square is equal to 9. So what do you observe? 1 does not equal to 9. So that means f of 1 does not equal to f of 3. But according to the Rolle's theorem, f of a must be equal to f of b in order to apply the actually Rolle's theorem. Now the Rolle's theorem cannot be applied because f of a does not equal to f of b. So hence Rolle's theorem is not applicable in this case also, is not applicable, right. Now let us directly switch over to the problem, that is Lagrange's theorem now. So let us move to Lagrange's. So problems on Lagrange's mean value theorem, LMVT. Now the second question note down. What is the second question now? Here, verify Lagrange's mean value theorem, Lagrange's mean value theorem for f of x equals to x minus 1 into x minus 2 into x minus 3 in closed interval 0, 4. So this is very important problem, very important problem, most expected question in the examination. Right. So first what shall we do now here? So according to the Rolle's theorem, already we have solved the problems. Now let us move to the Lagrange's mean value theorem. What does this state? So f of x is continuous in closed a comma b, f of x is differentiable in a comma b. So then there exists at least one value c belongs to the open a comma b such that f dash c is equal to f of b minus f of a. So that means c we need to find out in between 0, 4 interval. But for example, if you consider the function is x minus 1 into x minus 2 into x minus 3, you will get a cubic polynomial. So since it is a cubic polynomial, it is a continuous function and also derivable function. Two conditions has been satisfied. Only one thing you need to find out here. So c value we need to find out such that f dash c is equal to f of b minus f of a by b minus a. That's all. So hence the Lagrange's mean theorem will be verified. It can be verified. So let us solve this problem now. Solution right on. First of all, what is given here? Given that f of x equals to x minus 1 into x minus 2 into x minus 3. Let us simplify it. So x minus 1 into x minus 2 means x square minus 2x and minus x and plus 2. So multiplied with x minus 3, right? So then this can be written x square minus 2x minus x minus 3x plus 2. So multiplied with x minus 3. Again open the brackets, apply the distributive property. X into x square minus 3x plus 2. That is x into x square x cube, x into minus 3x square, x into plus 2x. Now minus 3 multiplied with x square minus 3x plus 2. So minus 3x square minus 3 into minus 3x plus 9x minus into minus plus minus 3 into minus 2 minus 6. So it can be simplified x cube minus 3x square minus 6x square 2x plus 9x 11x and minus 6. So this is the actually simplified form of the function. It is a cubic polynomial. Obviously it is a continuous function only in the given stipulated intervals. So that we can write now this one now. See, first point right up. F of x is continuous. F of x is continuous in closed 0, 4. Second one, f of x is derivable in open 0, 4. So for third, here, so let us consider here interval 0, 4 means you can compare with a comma b. So here a equals to 0 and b equals to 4. First let us find out f of 0. So f of a means f of 0. F of 0 means here substitute in this one 0 cube 0 minus 6 into 0 square 0 plus 0 minus 6. You will be getting minus 6. Am I right now? So next f of 4, f of b equals to f of 4. F of 4 is equal, better you substitute here itself only. 4 minus 1 3, 4 minus 2 2, 4 minus 3 1. 3 into 2 6 into 1 6. So f of b is positive 6, f of a is equal to negative 6. So we need to apply by LMVT, by Lagrange's mean value theorem, that we need to write it. So by Lagrange's mean value theorem, we have f dash c is equal to, so before going to that we need to find out f dash c also, that I will explain. First let us explain that one. Okay, wait a moment. So here f of x equals to what? X cube minus 6x square plus 11x minus 6. So differentiate both sides with respect to x. Derivative is very, very important. So differentiate both sides with respect to x. Differentiate both sides with respect to x. On differentiating both sides with respect to x, we have f dash x is equal to x square differentiation 3x square minus 6 into x square differentiation is 2x plus 11 into x differentiation 1, constant differentiation is 0. So we get 3x square minus 12x plus 11. So now find f dash c. In the place of x, write down c. So that is 3c square minus 12x plus c plus 11. That means indirectly we get a polynomial in terms of c. That is 3c square minus 12c plus 11. So by Lagrange's mean value theorem, we have f dash c is equal to f of b minus f of a divided by b minus a. F dash c we know this value. Let us replace 3c square minus 12c plus 11 is equal to c f of b. F of b is 6, f of a is negative 6, and a is actually here what? 0, b is equal to 4. Right. Here, since f of b is equal to 6, f of a is equal to minus 6, a equals to 0 and b is equal to 4. Once check it. C a 0, b 4, f of b 6, f of a minus 6. Right, clear? So let us replace it now. So let us replace this equal to f of b. F of b means actually 6 minus f of a, minus of minus plus 6 by b. B means 4, 4 minus 0, thus will be 12 by 4 equal to 3. So now bring 3 this side, you get now 3c square minus 12c plus 11 minus 3 equal to 0. So that implies we get 3c square minus 12c plus 8 equals to 0. So now we need to solve it, this one. We need to solve this quadratic equation in terms of c. So let us try to solve this one now. Right. So here once again comparing with ax square plus bx plus c is equal to 0, where x is c, don't worry. So we need to apply the formula method. What is the formula method? Actually we have c equals to minus b plus or minus root of b square minus 4ac by 2a. This is quadratic formula. So that means since here c square coefficient is a, here a is different 3, b is equal to minus 12 and c is equal to 8. So let us substitute. This is equal to minus of minus plus 12 plus or minus root of b square is 144 minus 4 into a 3, c is 8. So divided by 2a, 2 into 3. So this is equal to 12 plus or minus root of 144 minus 4 3 ja 12, 12 8 ja 96. So upon 6 you will be getting. So what is actually 144 minus 96? 144 minus 96 means you will be getting here 14, this will be 13, right? 14 minus 6 is 8, this is 13 minus 9 is 4, 48. This 48 we can write 12 into 4, you can write 12 into 4 or 6 into 2, yes 12 into 4 you can write, and also 3 into 16 also you can write, 16 into 3 is better one. So this equals to 12 plus or minus root 48 upon 6. This is 12 plus or minus root of 48. 48 we can write 16 times 3 upon 6. This is 12 plus or minus 4 root 3 upon 6. Take 4 common out. If you take 4 common out, what do we get? Let us see. So take 4 common out. See, if you take 4 common out, you get now 3 plus or minus 3 root 3 upon 6. So then what do we get now here? Otherwise take 2 common better. 2 common. This will be 6. Right. Take 2 common. 6 plus or minus 2 root 3 upon 6. 2 1 ja 2 3 ja. This will be 6 plus or minus 2 root 3 by 3. Whether we need to check that both the values lie in the interval or not. Yes, absolutely they belongs to 0 comma 4 itself only. 0 comma 4, because 6 by 3 is 2. Actually here 2 by root 3 is less than actually 1, you will be getting. Obviously 6 plus 2 root 3 by 3, 6 minus 2 root 3 by 3, both will lie in the interval 0 comma 4. Both lie in this interval. So that's why Lagrange's mean value theorem is verified. That you need to write it. So therefore Lagrange's mean value theorem is verified. See, very simple. Let me explain once again the method. So if you are asked to verify Lagrange's mean value theorem given function in the stipulated interval, so first write down f of x is continuous in the given interval, f of x is derivable in the interval, then find out is actually f dash x derivative, then substitute c, will get f dash c, then actually find out values a value, b value, f of b and f of a also. So f dash c is equal to f of b minus f of a by b minus a. Substituting, we get a equation, then we need to solve that. After that, whether we need to check the c value, do they lie, the values of c are either one value or at least one value should lie between the given interval. Then we say that Lagrange's mean value theorem is verified. That's all. In the simple manner we can solve this problem. Okay, let us move to the one more question now. One more question. So based on Lagrange's mean value theorem itself only, right? Let us proceed for that one now. So third question, third one. Verify Lagrange's mean value theorem. Lagrange's mean value theorem for f of x equals to x cube minus 3x minus 1 in closed interval minus 11 by 7 comma 13 by 7. This is the question. Okay, let us try to figure out this question now. Right. See, first write down given f of x equals to x cube minus 3x minus 1. Okay, first point write down f of x is continuous because it is a polynomial function, it is continuous. F of x is continuous in closed minus 11 by 7 comma 13 by 7. Second one, f of x is derivable in open minus 11 by 7 comma 13 by 7. Okay, third point. First f of x is equal to write down here x cube minus 3x minus 1, differentiate both sides with respect to x, differentiate both sides with respect to x, both sides with respect to x. So on differentiating both sides with respect to x, what do we get? So we get f dash x equals to x cube differentiation is 3x square minus 3 into x differentiation 1 and minus 1. Sorry, 1 differentiation is 0. So we get 3x square minus 3. Clear? So next, now let us say here a value is equal to minus 11 by 7 and b is equal to 13 by 7. Now let us find the values of f of b and f of a. Right. So f of a equals to f of minus 11 upon 7. So substituting here, what do we get now here? In the place of x, write down minus 11 by 7. Here also minus 11 by 7. So we are going to get minus 11 by 7 whole cube minus 3 times minus 11 by 7 and minus 1. So 11 cube, 11 square is 121, 11 cube is 1331. So but negative 1331 upon 7 cube, 7 into 7 49, 49 into 7 is 343. So negative 3 into negative 11, 33 upon 7 and minus 1. So let us make it simplify. You can make use of calculator also, no problem. So here 343, right? LCM minus 1331, right? 7, if 343 is divided by 7, you will be getting 49. Again 49 into 33, that is 1617 you will be getting. 343 into negative 1, negative 343. So first add 1331 and 343, subtract 1617 and put the negative sign. So that means we are going to get, that is minus 57. If you get simplify by 343, you will get it. Very simple. First add 1331 and 343. From this subtract 1617 and put. So you will be getting minus 57 by upon 343. So this is the value of f of a. So now let us move to f of b. We need to figure it out, f of b value. So f of b. So f of b means what is the value of b here according to the interval. So as comparing with the interval f of b here, f of 13 upon 7, right? This equals to, now we get substituting the function x cube. X cube means 13 by 7 whole cube minus 3x, 3 times 13 by 7, and we have negative 1, minus 1. 13 whole cube, 13 whole cube is 13 square is 169, 169 into 13 multiply. So you will get 2197 by 7 cube. Already we did in the last case while evaluating f of a, that is 343. So minus 3 into 13 is 39 upon 7 and minus 1. So let us simplify this one. So 343 is the LCM. 343 cancel, 2197, and 343 is divided by 7. So we get 49. 49 into 39. 49 into 39 is actually, here you will be getting 1911, but negative is there, negative. 343 into minus 1, minus 343. Simply add these two and subtract from 2197. So that we are going to get that value is equal to here f of b. So the f of b value will be very interesting value, you will get it now, that is 57 upon 343 you will get it, whereas f of a is negative 57 by 343. So now apply Lagrange's theorem. So by Lagrange's mean value theorem, we have, so f dash c is equal to f of b minus f of a upon b minus a. So let us substitute values. See what is f of x here. So you check. See f of x is equal to x cube minus 3x minus 1. F dash x is equal to 3x square minus 3. So obviously f dash c means here 3c square minus 3. You remember this one, that's all. So 3c square minus 3. 3c square so this is 3x square minus 3. F dash c means 3c square minus 3. So this we can write now 3c square minus 3 is equal to f of b. F of b means 57 by 343 and minus of f of a. F of a is minus 57 by 343 divided by b minus a. B minus a means b means 13 by 17. So a means actually minus 11 by 7. So good morning Sakam Monica, welcome. So b minus a. B means 13 upon 7 and minus 11 by 7. So we need to simplify. So let us simplify this one. Let us see what do we get now. This is equal to. See, very interesting actually here. Wait. Here actually you get minus 57 by 343, Nana. Okay. So I forgotten actually minus 57 you will be getting. Here minus 57. So minus 57 by 343 minus into minus plus 57 by 343 by here 7 is the LCM, 13 plus 11. So minus 57 by 343 plus 57 by 343 will get cancelled. We have 0 by something, that is actually here 24 by 7. So you will get 0 itself only. 3c square minus 3 is equal to 1, you will get it. So divide both sides by 3. Actually we have 3 common. C square minus 1 is equal to 0. So that implies c square minus 1 is equal to 0. So that implies c square is equal to 1. C is equal to plus or minus 1. Because c is equal to plus or minus root 1 plus or minus 1. You need to check whether 1 belongs to this interval or not. Obviously 1 belongs to the interval, negative 1 belongs to interval. So therefore we can write this c is equal to plus or minus 1 both belongs to open minus actually 11 by 7 comma 13 by 7. Hence Lagrange's mean value theorem is verified. That's all. Right. So now one more very interesting problem now we are going to solve. That's very important. You must remember always. See. Okay, this is the problem now. Now let us move to the fourth question now. Fourth question. When 1 minute will complete. Fourth question. Verify Lagrange's mean value theorem for f of x is equal to log x to the base e in the interval closed 1 comma e, closed 1 comma e. So let us verify. Right. Okay, let us try to figure it out, this one now. Solution, let us write. Saka Maunika. Okay, f of a minus 57 by 343. F of b. Let me check once again. Let me check. I will check it now. I will check it. So let me check. Okay. After completion of this one, I will come to the Saka Monica. Okay. I will check it later. Don't worry. Okay. Let us solve this. Try to solve this problem first. So given f of x equals to log x to the base e. So first one. So log x is continuous in the interval g 1 comma v, because x must be greater than 0 itself only. So that means actually here f of x is continuous in closed 1 comma e, the first point. Second point, f of x is derivable in open 1 comma e. Third point. So as we have f of x equals to log x to the base e, differentiate both sides with respect to x. So on differentiating with respect to x, so what do we get? It becomes f dash x. The derivative of log x to the base e is 1 upon x. Clear? So now here let us say a equals to 1 and b is equal to e. Now let us figure it out, f of a value. F of a equals to f of 1. That means we are going to find out f of 1. F of 1 means logarithm of 1 to the base e. Log 1 to the valid base is always 0. Log 1 is 0. So f of b is equal to f of e, right? Log e to the base e. Log e to the base e is 1, right? So now here by Lagrange's mean value theorem, we have f dash c is equal to f of b minus f of a, by b minus a. So f dash c, as f dash x is equal to 1 by x, f dash c is 1 upon c, is equal to f of b is 1 minus f of a 0 by b minus a. B minus a means e minus 1. Right? 1 by c equals to 1 upon e minus 1. By cross multiplication, c is equal to e minus 1. So approximately e is 2.3. 2.3 minus 1 is 1.3. Obviously it lies in between 1 comma e itself only. So therefore c is equal to e minus 1. That belongs to open 1 comma e. So therefore the Lagrange's mean value theorem has been verified. That's all. Lagrange's mean value theorem is verified, only statement you need to write. That's all. It's very simple problem, very simple problem. So hence Lagrange's mean value theorem is verified. Right. Let us move to one more interesting problem, that is actually right. Okay, here actually Shakam, Monica asked the doubts. Let us check once again here now. See, 19, 11 plus 343, 4, 5, 12, 1, 20, 24. So, 20, 20, negative 20, 24 and plus 2197. So, you will be getting negative 57. Okay, are you correct now? Right, this also f of b also you will get negative 57 by 343. So, since f of a is equal to f of b, obviously 0, f dash g is equal to 0, we get c is equal to plus or minus 1 itself only. Right. Next, fifth question. See, this fifth question is very important problem, very important problem. If a less than b, prove that b minus a divided by 1 plus b square less than tan inverse b minus tan inverse a less than b minus a by 1 plus a square, using Lagrange's mean value theorem. So, this is very important problem. Just better you practice 2 or 3 times. So, it's very clear. Once again, check the question. All of you read the question carefully. Look at the screen. Shaka, Monica, are you there? Yes or no? Simply you try to concentrate on this part. So, this is tan inverse b minus tan inverse a, means this is nothing but f of b minus f of a. F of b is equal to tan inverse b or f of a is equal to tan inverse a. Obviously, our function becomes tan inverse x. So, in order to determine the function, we need to focus on this one, that is tan inverse x form. So, f of x is equal to tan inverse x. So, this is our interval a less than b. So, a less than b means interval becomes a comma b, either closed or open interval. So, first we need to define the function, then we need to apply the Lagrange's mean value theorem, so that we will get whatever condition they are asked. So, first of all, the very important step is to determine, to find out the function, which function is there here. So, now let us proceed for the solution now here. Right. So, let f of x equals to tan inverse x. Tan inverse x in closed a comma b. See, the tan inverse x is continuous only as we are to prove this one, already the Lagrange's mean value theorem satisfies all the conditions itself only, so that directly we can proceed here. So first find f dash x. So f dash x means different derivative of tan inverse x, standard result 1 by 1 plus x square. Now find f dash c. What is f dash c? F dash c is equal to, so 1 upon, here this will be c 1 plus, right 1 plus c square. F dash c is equal to 1 by 1 plus c square. So by Lagrange's mean value theorem, we have f dash c is equal to f of b minus f of a by b minus a. F dash c means 1 upon 1 plus c square is equal to f of b. So that means now we need to evaluate f of b, f of a. F of b means in f of x, substitute x for b, you will be getting tan inverse b minus f of a. F of a is equal to tan inverse a by b minus a. It is clear that tan inverse b minus tan inverse a is the part of our problem. So this one, tan inverse b minus tan inverse a, already it has been highlighted by me. Say this is equation 1 now. Say this is equation 1 now. So very interesting. So now we are able to establish the relation between 1 by 1 plus b square and 1 by 1 plus a square to the 1 by 1 plus c square, so that we can get our required value, can be our target proof will be obtained here. So for that, here consider this one, here a less than b, squaring on both sides. So if you squaring on both sides, what do you get? A square less than b square. The inequality symbol will not change. You remember one thing. So now add 1 on both sides. Add 1 on both sides. Adding on 1 on both sides, what do we get now here? This inequation becomes very interesting. 1 plus a square less than 1 plus b square. Clear? So and also one more thing, instead of writing all these steps directly also we can proceed. What is the direct step means? Let me write the c value. Already we know that here the c value belongs to here, c belongs to a comma b. Since c belongs to a comma b, c lies between a comma b. So better you write down like this, a less than c, c less than b we can write. And squaring on both sides. Squaring on both sides. On squaring on both sides, very interesting. What do we get? A square less than c square, c square less than b square. So add 1 throughout. So that means we get 1 plus a square less than 1 plus c square less than 1 plus b square. Clear? Reciprocals write down. When you write the reciprocals, very important thing need to be kept in your mind, that inequality symbol reverses applying reciprocals, that is 1 upon 1 plus a square greater than 1 upon 1 plus c square. This is the only the thing need to be manipulated here. So greater than 1 upon 1 plus b square. So now same can be stated as 1 upon 1 plus b square, we can write less than 1 upon 1 plus c square less than 1 upon 1 plus a square. So from equation 1, now the 1 by or 1 upon 1 plus c square is replaced by tan inverse b minus tan inverse by b minus a. That means in the place of 1 by 1 plus c square, we need to write this one now. So that means in the next step what we are going to write? So from equation 1, we have 1 by 1 plus b square. See, 1 by 1 plus b square less than tan inverse b minus tan inverse a upon b minus a less than 1 upon 1 plus a square. The only one step is there now. So, multiply this inequality with b minus a. Then what do we get? B minus a into 1 upon 1 plus b square, it becomes therefore b minus a upon 1 plus b square less than, see, b minus a into tan inverse b minus tan inverse a by b minus a. B minus a will get cancelled. We get tan inverse b minus tan inverse a and less than b minus a into 1 upon 1 plus a square, you get b minus a by 1 plus a square. Hence it is proved. Hence it is proved. It's very, very interesting problem. Application of Lagrange's mean value theorem. So, once again go back and you can check it now. How did you prove this one? So, in that one more 2 sub questions will be there, that also we are going to discuss. So, that also we are going to discuss. Okay. Right. Okay. Now we shall discuss the remaining problems tomorrow also. Right. Bye bye. Right. See you.